everyone, my name is Dolph and I will be guiding you through today's lesson. In this lesson, we will be exploring activities for the Grove Light Sensor module. A Grove Light Sensor is a module that is used to measure light intensity. It is an analog component much like the potentiometer with values ranging between 0 and 1023. The light sensor doesn't have a knob to vary these values, thus, it depends on the light intensity it detects. This has been a useful component for various reasons, such as detecting movement, tracking the movement of the sun, and automatic lighting. For our first activity, we want to know the values the light sensor provides through our serial monitor. Note that if you haven't taken out the module from the breakout board, there is no need to connect them using the Grove cables, because these modules are already connected to the Grove base shield. In this video, I am only presenting to you how to connect the modules on the shield, assuming that the modules have been taken out of the breakout board. We plug in the Grove Light Sensor module to the analog pin marked A3 on our Grove base shield. Once it's connected, attach the shield to your Arduino Uno and connect it to your computer.
The first thing we will be doing with our light sensor will be similar to what we did with our potentiometer. We will measure the analog output and display it in the serial monitor. We first define the light sensor pins. Then we introduce a variable input val. And on our setup, we declare our light sensor as an input. And we will also set the data rate in bits per second. In here, our speed will be 9600. And on our main code, we use analog read to read our light sensor. And display the values on the serial monitor using serial.println. We then save this file and upload this on our Arduino. When you open the serial monitor, you should notice that the value changes whenever the light intensity that is directed to the light sensor is varied.
Now, the values that we obtain may differ because of our setting. Just note the maximum value that you got. This will be used for our next activity. For the setup, we connect the Grove LED to the digital pin marked D6 on our Grove base shield.
So our second activity, we will be integrating LED with our light sensor. To do this, we first define the LED and its pin, and introduce a new variable which is output val. And don't forget to declare LED as an output in our setup. Now on our main code, we map the input value, which is 0 to 749. This is the maximum value we measured on our first activity. Then scale it to 255 to 0 so that our LED will operate inversely from the values we measure from the light sensor. Thus, when there is sufficient light detected, LED will start to dim just like our mobile phones. In order to vary the LED output, we use analog write. So once you're done with the code, save it and upload it to your Arduino. You will notice that when it detects a value around maximum, our LED starts to dim. If this doesn't happen, maybe your maximum value differs from mine, so you can also do the first project again to note what the maximum value your light sensor gives off.
For the setup, we just add the buzzer by connecting it to the pin D5 on the Grove base shield.
Our final variation for the light sensor is integrating it with a buzzer. So what we do here is we define the buzzer pins, declare the buzzer as an output on our setup, and on our main code we use tone, buzzer, then multiply the output value to 5 to increase the frequency of the tone, and upload the code to the Arduino. As the light intensity increases, the buzzer will start to fade out. What you can also do is introduce a conditional statement to set whenever you want the buzzer to turn on or off. Since we have done similar activities, you can use that as a reference.
Now that is it for this lesson. To learn more about the other modules, simply head on to the next video.